Okay, in last lecture we discussed about the types of discontinuity, removable and non-removable. And in removable, we had two types of discontinuities. One was missing point discontinuity, and second was what was the second discontinuity in removable? Can you hear me all? Okay. Can you see?
Yes, sir, continue.
First was missing point discontinuity, second was isolated point discontinuity. And in non-removable discontinuity, we had three types of discontinuities. One was finite type, in which both the limits exist, but they are not equal, and both are finite. In second, we had infinite type of discontinuity, in which one may or may not exist, or one is infinite. So in that case, we had infinite type of discontinuity, and these are obviously non-removable. Or in finite case, we call it jump discontinuity. And in third, we have oscillatory, where our limit is oscillating. It's not existing. It can take some. It can take any real number, or in some interval, it can take any real number. Yesterday we saw about this last function sine pi divided by x, or we can say sine 1 by x, that is also taking values between 0 and 1, and minus 1 and 1, which can take any real number between minus 1 and 1. It will oscillate between minus 1 and 1 infinitely many times. So every point will be the limit point of this function. So talking about these functions, try these functions. F of x equal to greatest integer of x at x equal to 0. Check uh, is this function continuous? If not, can we redefine this function at x equal to 0 to make it continuous? Try first one. F of x equals to. If we take the graph of this function at 0, it is this, and here 1, let's say. This is graph. Okay, I will write the graph with red. This is first, and this is if we take limit x going to 0 minus, then f of x will give us minus 1. If we take limit x going to 0 plus f of x will give us plus 1. And what is functional value? F of 0, f of 0 is 0. Left hand limit is not equal to right hand limit. So it is not continuous. It is discontinuous at x equal to 0. But both the limits exist and are finite. So we can say it has finite type of discontinuity at x equal to 0. Is this removable or non-removable? This is non-removable. Finite type of discontinuity at x equal to 0 and which is non-removable. Second example is f of x equals to greatest integer of x plus minus greatest integer of x at
Sir,
yes,
previous one, how it is non-removable?
we cannot redefine the function at this point 0. How can we? We cannot. If it was like this, only one point, our functional value is like this. We can redefine this. Here we have two separate branches. We cannot redefine them. At this point, if we take, let's say we take this as right, we take any point in between them. Still, the limit does not exist. Okay, let's say f of x equals to when x not equal to 0. Okay, let me give you the last warning about this. You are making fake accounts and joining, then commenting very bad things. It's not fair. You have been shared link. We have made separate group last time when we inquired about this, and you told that this can be any person from the group. But now there are only 5 people in this group. So be careful. We know there will be your career will be over if you do like this again and again, coming and making wrong comments here. So be careful. This is last warning. Otherwise, I have to inform police. School already informed. Now we have to inform police about this. Then we cannot save your career if you are anyone. Okay, let me get back to the class. F of x equals to greatest integer of x plus greatest integer of at x equal to 1.
Sir, what? Sir,
Okay, let's start this question. F of x equals to gif of x plus gif of minus x at x equal to 1. Take LHL, left hand limit, at x equal to 1. So limit x going to 1 minus plus minus. So this is h going to 0, x 0 minus h.
sir,
We are taking limit at 1, so 1 minus h.
sir,
Yes,
explain yesterday's questions.
1 minus h plus minus times 1 minus h. Limit h going
Sir,
to 0. First, let me do this, then we will see what. So 1 minus h. H is not equal to 0, but it's tending to 0. So 1 minus h, it's on the left of 1. So this will become 1 towards left of 1. So it will be 0. So this will be 0. Its limit as h goes to 0, this will become 0. Greatest integer of 1 minus h is 0 plus this is greatest integer of minus 1 plus h. Minus 1 plus h. When it is minus 1 plus h, it will go to minus 1. So it is, this is 0 plus minus 1, which is minus 1. Now RHL, so limit x going to 1 plus this plus minus. So limit h goes to 0, 1 plus h plus minus times 1 plus h. This will go to 1 only, towards right of 1. So greatest integer of 1 point something, 1 plus epsilon, 1 plus delta, which is very close to 0, 1 plus h is very close to 0. It will give us 1, and this is minus 1 minus h. Minus minus 1 minus h, which will give us minus 2. So for minus 2, which is equal to minus. So we got left hand limit equal to right hand limit. And what about the value of function? What is f of 1? F of 1 is this plus this. This will give us 1 only, and this will give us minus 1, which is equal to 0. So limit x going to 1 minus f of x equals minus 1 equals to limit x going to 1 plus f of x. LHL equal to RHL, but not equal to f of 1, value of function. It is discontinuous at f of x is discontinuous 0, x equals to 1. So which discontinuity it has? Isolated point. Left hand limit equals to right hand limit, not equals to value of function, means isolated point of discontinuity. So we can also redefine this function f of x mod x plus f of minus grf not equal to 1 and minus 1 when x equals to 1. Now this function becomes continuous. Is this clear? F of x equals to e to the power 1 upon x at x equal to 0. Now LHL is limit x going to 0 minus e to the power 1 by x is equal to limit h goes to 0 e to the power 1 divided by 0 minus h, which is equal to limit h going to 0 e to the power 1 divided by h minus time. So as h goes to 0, as h goes to 0, 1 by h goes to infinity, and minus 1 by h goes to minus infinity. So otherwise I can write this as 1 by e to the power infinity. E to the power infinity is infinity, so 1 by infinity is 0. This will go to 0. Now RHL, limit x going to 0 plus f of x equals to limit x going to 0 plus e to the power 1 by x equals to limit h going to 0 e to the power 1 divided by h. 1 divided by h is e to the 1 by 0 is infinity, which is e to the power infinity, which will go to plus infinity. So LHL equal to 0, RHL equal to plus infinity. So which type of discontinuity we have here? Limit does not exist. We can say here limit does not exist. So it has infinite type of discontinuity. Infinite type of discontinuity at x equals to 0. So can we redefine this function? No. This is non-removable type of discontinuity at x equal to 0.
Sir,
Yes.
solve yesterday's question, sir.
Yesterday's question. Which question?
Third question.
Tell me. Third question, everywhere continuous. Tell me the question.
1 by x power 4 plus x square.
1 by x to the power 4 plus x square plus 1. Can we write this 1 divided by x square plus 1 by 2 whole square plus 3 by 4? Otherwise, if you did not get this, put x square equal to t square plus t plus 1. This can be written as t square plus t plus 1. This can be written as t square t plus 1 by 2 t. Then we need 1 by 2 square, which is 1 by 4 minus 1 by 4. Then we have again 1 here. So this will become t plus 1 by 2 whole square plus 1 minus 1 by 4 is 3 by 4. So this can be written as x square plus 1 by 2 whole square plus 3 by 4, which I have written here. This is always greater than 0. This x square plus 1 by 2 whole square is always greater than equal to 0. And this is always greater than equal to 3 by 4. So it is never equal to 0. So nowhere discontinuous. There is no point at which it is discontinuous. We can say f of x is continuous for all x belonging to R. Is this clear?
Yes, sir.
Do you need further explanation for this? Who is Anjali Budali? Who is this Anjali Budali? Hello.
Don't know, sir.
Who is this Anjali Budali? Can you turn on your screen? Is this video? Hello. 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 Hello, Anjali Budali. Hello. Can you turn on your camera? See, this link was sent to only 5 people or 3 people in this group. And for separate link from Govindu sir, that was sent to biology people. So there are only 3 students who are, they should be in my class. But if there are coming some other students, so either it is shared by you or you are one of them who is making one more account and coming.